Do you know that you can use now Maya, Arnold, and Bifrost USD as a suite of tools for look development, layout, and lighting? This alone empowers artists to create USD-based scene graphs that go from master creation to a final render. Hello everyone and welcome to my channel. I'm JP, and in this video I'm going to show you how I built this scene using only USD across Maya's tool set. Today, you're going to be learning how to set up models for export. You're going to take Arnold's latest plugin in order to export and keep all these shading, texturing, and lighting data inside of the USD container. Then we're going to be using Bifrost to define variants. And I'm going to explain what variants are inside of the world of USD. Then we're going to create USD prototypes in order to create an entire building out of just one particular module. A USD Point Instancer in order to create an entire city out of just one module. So let's do it. Alright, so we are inside of Maya now. So I have a model which I build, right? So what I want to do is just take this module, which has textures, we have shading information that I'm going to show you right now. Just let me click render so you see. And I'm going to make sure that everything, so the model doesn't have any errors, doesn't have manifold faces, concave faces, the UVs are laid out properly. I want to make sure that everything works inside of my model. And this is very important prior to exporting this as USD data. So, as you can see, I have very nice shading information inside of my model. I have a lot of stuff in here, so you can see I have even a man inside of the pod just to replicate exactly what you see in the Matrix city or the Matrix movie, right? So let me stop this now, and I want to show you and explain how I've done this and why, of the logics behind it. So first, as you might see, I have this pod, right? So I separated everything, didn't separate these for arbitrary reasons. I did this intentionally. Why? Because every single piece or group that I have here has a different shading network applied to. So I have the pod with one shading network, cables with another shading network, this one has another shading network, and you get the deal, you get the story, right? So on and so forth. Once I have everything checked for errors, and that means going either retopologizing if needed, or cleaning up the model and making sure none of these stuff have errors. But first, let me explain. In previous versions of Maya, you would not be able to keep this Arnold information. You would have to export as Arnold USD, which is not the case anymore in the latest version of Maya. So now what you can do, you can pretty much export same way you used to, USD, but now we have a file type specific option right here. So plugin configuration need to be set to Arnold. Why? Because then you're going to be able to keep all this shading, texture, and lighting information inside of the USD container. So you don't have to have separate files or work separately. I mean, everything works together now across Maya's tool set. One thing that you also need to make sure is that you create a USD parent scope. This is just the name of the USD scope that is the parent of the exported data. For example, if the string salad is entered, the following code is included in the USD file. This is how you're going to be exporting from Maya. So once you're done here, you're all set. I don't want to use animation range. I don't want to export animation whatsoever. I export, and then I just basically can give it any names. So I could basically pretty much just export that replace it, whatever, right? So that's done. Next, I'm gonna show you how to import this USD data from Bifrost and Maya and see how it renders, just to show you how it keeps all the information. As you should know by now, there are multiple ways to import USD data into Maya. So you can either go directly into the file, import Maya data through the import options here, or you can go into create and scene, universal scene description, and you can do, say, for example, stage frame file, or you can also go from Arnold and create a stand-in and bring it in to USD data. So the way we're going to be doing it this time around, we're going to be using Bifrost. So this is the new way of importing or creating or dealing with USD data inside of Maya. So all you need to do is just create a new scene graph, and basically I'm just gonna, first thing I want to do is just add a USD to stage. That creates a node, pretty simple, right? I don't need this particular info, so I can delete that one. And so what I want to do is pretty much just create a node, which is a defined USD prim. So I'm going to click in there, and as you might see, I have different things that I can do. I can define variance here. I can create a reference definition, children's, for example, a lot of stuff. So, but one thing I want to do just to keep this simple, low level, is just to create a reference definition. So if I do that, I just right clicking on top of that, and you see I have a create node. I'm just going to do create a reference node, and I have a layer. So what I want to do is just create a new USD layer, and now I can go ahead and find, let me click in there, sorry again. I'm just going to go find my USD file. Okay, so once I have found my USD file, all I need to do is just pretty much just add it to an output. As you can see, now I have pretty much a Bifrost graph here, and it just brings all the files as an obj. So this is the name of the particular file. So if I go back into here, you can see whenever I create an X form, it gives me an obj name. So all I need to do is basically just change that into, say, for example, pod, click enter, and as you can see now, it's got a new name now. So you can also refer to this as the prim path, which is just the path where this primitive lives inside of Maya. Just basically just renamed the group pretty much. That's all I did. So as you can see, then I have the pod group, which was initially there with all of the subgroups and all the stuff that was exported. I also have all of my shading information, as you can see over here. I have like the looks over here as well. So I have pretty much everything contained inside of this USD file. So next thing I want to do is just click render just to see, if all of my shading, texturing, shading information is being kept and respected by the USD export. Voila! As you can see now, you can export USD files and still keep all of your shading, texture, and lighting information inside of the USD container. Next, we're going to see how you can create these variants with multiple modeling, texturing, and shading changes, and also repurposing the USD file so you have a proxy version that only shows at the viewport and a render version that also you're able to change, depending on whatever you want to render, say, variants that you have saved. Back in Maya, I want to show you first where the prototype looks, or the one that I built that looks inside of Maya. And then I'm going to show you step by step how to recreate or rebuild this inside of Bifrost. And this can work with any of your models. It can work in any other example. It doesn't really have to be tied to this particular one. So if I click here in this particular Maya USD file, you will see that I have a stage display, right? So a porpoise pretty much. At the moment I have set it up to render, and that's why you see a full version of it. But if I unclick that and I just click on the proxy, you see I'm also able to show you just a very low level or low res version of my pod. So going back to render, I also want you to notice that I have here the two ones. So I have a pod render, a proxy, but I also have variance here. As you can see in these particular group, or let's call it transform, there's a V. That's pretty much a representation inside of Maya that tells you, or an icon that tells you, hey, there are different variants in this particular file. So if I right click on top of this, you will see I have different variants, which are called pod variants in my case. So I have one variant which has a pod lights on, pretty much. I have another one that has all the lights off, and I have another one which just have this open, so I can have a character, you know, inside of it or sticking out or whatever. If I click on this pod variant or to open, just watch out what's going to happen. It's just going to swap my USD reference for another one. But how does this works? In a nutshell, imagine the USD container is a cabinet that has different drawers, and then you can put every single model, change, texture, line information inside of one of them drawers. It's as simple as that. Now inside of Maya, let's dissect exactly how I build these different variants and how I purpose it so you can have a proxy version and a render version inside of the viewport. So that's pretty much it. As you see here, there's not much. This is not very complicated network or graph. So don't you worry, I'm going to be sharing all this with you so you can reuse it. You don't have to redo this in any case. But if you do, it's as simple as going like this. So I'm just going to replicate what I did here, and I'm going to explain step by step. So first thing you want to do is always start with an add to stage. So add to stage is just going to create the very first thing you will see around here. As you might notice, at the moment we have nothing because we haven't created an output. But if I do say create or connect this to a particular output, so let's do that, create that. Now we have a new Maya USD proxy 2. So, but if I go inside, there's nothing. So same deal as the other one here. So I have nothing at the moment. So let's go back into here and let's start creating then this whole thing. So or recreating this whole thing. So basically I'm just going to right click. I'm going to go into create node. I'm going to start defining a very first prim. So the very first prim that I define is just an X form. As you might see, it's got the name obj by default, which is the prim path. So I'm going to rename that to say example. And that really doesn't matter. At this point, if I click here, you will see that everything remains the same. There's no changes in here, set, just changing the name of the path, of the prim path, right? So next thing I want to do is to start setting up a variance set. So creating a variance set. So again, I just do a right click on top of variance sets, and let me get a bit closer here. Right click and just create a new variance set. Whenever I get a variance set created, it's going to ask me for a particular name. So I'm going to call this variance. It doesn't really matter what name you give it. It's just a way to know, doesn't really matter what name you give this. So it's just about naming it. So selection is the very first one that you want to have selected by default. So let's call this the selection or variance 01 for the very first one. Doesn't really matter, right? So now it's time to start giving this some purpose. So let's now see what happens if I go back to Maya. What do I have in here? So what I have at the moment is just another X form or transform with already a variance set icon in there. That means this variance, but at the moment there's nothing's being created, so it doesn't really matter what I do. There's nothing gonna be showed. So let's go back here, and what we want to do next is just create another X form, but this time around it's going to be a children, and I explain why. Because I want this to be underneath, right? Underneath the rest. So that's going to go here. And for this particular children, this one's going to call it example render, basically, or purpose, whatever I want to give it. So let's call this example render. Okay. So as you might see, this is the one I'm going to be using. It's the same as I have here. So basically all I want to do in this case is change the purpose of this one from default to a render. This means that whatever is connected as a children underneath this particular X form is going to be used just to render times, unless I decide to change it. Where am I going to change it again? Basically, if I click on top of the hierarchy, you will see I have the proxy and render. I have the purpose right over here. So I can select which one I want to have display in the screen. Same that we saw before here, right? So that I showed you before. If I click and unclick, then I can just basically specify which one I want to create or which one I want to display, sorry. So let's go back into Bifrost, sorry. And next step is going to be to create then another children. And this is where we're going to start referencing in the USD layers or variants, right? So very first one, again, see, notice, always got the OBJ name. Let's call this variance 01 for this particular example, because the purpose was defined before at the top level node. All I want to do now is to basically give it a name. So I need to go and grab my variance set name, which I define over here. It's called variance, remember? And I'm just going to put it in here. Remember I said this is going to have a selection. So the very first one is going to be this one. So I'm going to copy that as well. I'm going to paste it here. So this is the very first name of this variant. So pretty much, what else I need to do now? Let me save this. Now that I have this, I can pretty much just bring in a new reference definition, just a new layer pretty much, right? So go find my USD file. And that's what I'm going to do now. So same deals I showed you before. So I'm going to go into the layer, create a new layer, and then I'm going to go grab my USD file. So this USD file, let me go grab it. Okay, so that's here now. So let me just hide the one on top, and I'm just going to bring in this one here. So this example, you see, this is what I have at the moment. So it's just that one there. By default, so let's go back into the attribute editor. It's actually looking just for a proxy now. So that's why I don't see anything on the screen. So if I go click and check on render, now all of a sudden my stuff appears, right? So as you can see at the moment, I have a variance set declared called variant, and I only have one variant. So now it's time for me to start adding different versions or variants of this. And at this point in time, this is as simple as just creating as many as I need from this particular children. So at this point, at this level. So basically it's just the same. It's just create a new X form. Now I'm going to call these, say, var02. And so on and so forth. So now I'm just going to speed up the process, and I'm going to go get all the other two variants that I had, and then I'm going to show you the result. All right, so now that I have created all of them, let me go back to Maya, and now I'm going to show you what I have here. So at the moment, I only have this render example with just that particular X form. If I right click on top of this X form node, you see I have the variants that I just created. So the variant, the very first one, which is default. Then I have an open version, again, like I showed before, which is that one there. If I click, you will see the model changes immediately. And if I click on the off version, there's also a different model change. So let me go back to the default, and you will see it jump. A little bit of a change was there. Not big one because it's just off and on. But yeah, you get the deal, right? So next step is then now to create a proxy version of the pod, so I can basically swap between those two and, you know, regain certain or optimize my viewport, you know, whenever I need to have a lot more versions of this in screen. So that's what we're going to be doing next. So same kind of thing here. So as you might see, they're all coming from the very first one here. So like I said before, so I have an example render, and I'm going to create another children. And I'm going to call this example proxy. Right? So in this case is the default. I'm going to change the purpose from default to just proxy. And because this is not going to be part of this variant, I don't really need to declare or do anything else here except from creating a children and go grabbing my stuff, right? So I already declare here that this is the proxy. So now I'm going to create another children, which is this. By the way, in order to collapse, it's just hitting the number 2 in order to make it smaller. Now I can go and get my reference definition. And lastly, again, one thing. I'm going to grab my proxy. But now that you have seen how to replicate this entire thing, I'm just going to pretty much just going to delete this one because I don't need it. I already have it there, as you might have seen, pretty much. And I'm going to move on to the next step, which is now is creating a particular prototype, which is over here, right? In order to construct points, you know, and pretty much use that thing that we built here. So these pod X forms going to be used in order to now create an entire building. So let me illustrate. I'm going to go into my construct points here. Let me go back and unhide this, right? And I'm going to use my proxy version, right? This is the reason why I use the proxy version. Now, what I want to do, what I'm going to show you now, or how to build this, is this. Pretty much creating instances of that same one and a particular radius, and then I'm also going to instantiate them on a vertical point. So in this case it could be any amount, so it could be 30, it could be 60, it could be 100, and let me show you how quick this goes. So you could take the grab this and just move it like that. And you get an instant feedback of that by just moving that there. So this is how we're going to be building this entire tower. Let's call it a tower. One little thing I want to pay attention to is, you know, the amount of FPS over here, right? When I use the proxy. That's the main reason why we actually using proxies instead of the full version of the pod. Even though USD is very fast and you will be able to load millions and millions and millions of polys in like 3 seconds, you're still going to lose a lot of performance. So let me demonstrate that. I'm just going to swap from proxy to a render. And that should take like 1, 2, 3 seconds in order to load all of them, as you might see there. Now we have full versions of the pod, right? But watch out for the FPS. So now I have 2 frames per second. I'm still able to move. But it's really, really hard to move. So it's 2.1 frames, it's not optimal. So that's why we created the different purposes, right? So we define different purposes. What we're gonna do next, I'm gonna show you how this works, right? And after this, we're gonna see how to create then the entire city, and finally we're gonna render it. So let's move on. Okay, so in order to get the tower, the building ready, I first needed to figure out how big I wanted this to be. So what I did was to first create a cylinder, right? So cylinder, I happen to know is 2012 in order to match the distance that I wanted to have here. So this is how big I wanted it to be. So once I figured that out, I also needed to know how many subdivisions, I needed to in order to match the size of this guy. So I came around to 7 subdivisions, right? And how do I know that? Because I positioned it in such a way that, okay, this is pretty much the same size. So now I know I need 27 of these pods to be instantiated or copied around this circumference, right? So this radius. So basically, how do you do that in normal, regular Maya days? It's basically you select your object and then you just pretty much just move the pivot by holding D and just like this, right? Holding D down and moving the pivot around and just center it and snap it to the right to the middle of that particular cylinder. So there's 2 ways you could do this. You could either do it in Maya directly by cloning and doing all this stuff, but I wanted to do it procedurally inside of Bifrost. So I asked one of my colleagues to kind of help me construct the points in a way that would match this idea. And this is exactly what they did. So let me show you how that looks inside of here. So basically he created a particular node, which is called construct points Rdc. Basically radial, if I select this, you see I have a radial count, vertical count, and I have a height. The height is set to 649 because I happen to know that if I wanted to move this and then have a copy right on top, I will need to displace these 649 units. So basically I would need to do this 649 in order to get to the same, or basically to have another story or another level of this. Okay, so that's how I know or how I figure out this particular number here. So what it went ahead and did is, if I just explode or open this one here, you will see this basically creating or building the points, right? Getting them in an array, so put it into a particular array, and then he's using a pi node, a mathematical basically node, which is just a way to calculate the ratio of the length of a circumference to its diameter in specific Euclidean geometry. And then basically he connected this he converted this into radians. Why is that? Because basically all of this, what it does is just to figure out the distance that I have between this guy, or basically this, let me select it again, let me go back into here, and this pivot, right? So it's figuring out the distance between the middle, right, of this circumference and where its position is. So basically you can rotate and do this, 27 times. So that's pretty much it, right? So that's what I'm trying to explain here. It's not really that difficult. Don't you worry. I'm going to be sharing these compounds with you so you can dissect them, you can have a look at them, and recreate it yourself. One thing you need to know is that I did it this way. So if you want to kind of reuse this particular node or this particular compound, you would need to re-export the USD file from Maya. And if you say you wanted to move the pivot, so right, say you wanted to make it a bigger circumference or a bigger radius, then you have obviously to move the pivot, and you would have to re-export as USD once again. So that's how that need to be done. So next step, right? So in order to create or separate, say, this from this other guy, from this stage, I basically created another stage. And why? Why there's another stage? As you might see, I have the top parent, which is the my USD proxy shape. Then I have the pod as one group.
Then I have the tower building, just making sure I create a building as another group or another section of this USD file. And then I have the city as another section. So I want to separate this because I want to use this print path in order to recreate or make the whole thing inside of Bifrost. So again, I added the stage, I added a new stage, I connected the one we have previously into this one, and then I created a new prim. So again, a new prim is just basically just to define an X form. As you might see, if I click here, you will see the definition is an X form, as you might see here, and basically just give it a name. I called it tower building, which is exactly what we're building here. And everything else remains the same. On a children level, so I wanted this to the point instancer to live inside of this X form. I'm just gonna create another node, sorry, which is this particular one here. So it's a defined USD point instancer. So if you click in there, that's gonna create this other node. And let me expand this a little bit. You will see what he has is basically obviously you will have an instancer path, which you have to give it a name. Obviously by default it would give you, I think it's the OBJ thingy. And actually let's have a look at that. So if you create a new one, say point instancer, it's just called instancer pretty much. So just give it a name, and you see on the selection tab you can either do random, sequential, that in case you have different points or different references, right, that you want to use. In that case, you can randomly assign these different ones. So say I had different pods with different versions or whatever, not variants, but different actual versions of the pod with different cable arrangements and such. Then you can use them here, and then you can obviously randomly assign them or sequentially assign them. Then you have the ability to change that particular curve, and you can do pretty much a lot of good things. One thing you should know is that by default, it creates default override material. So you need to uncheck this because by default, it gets checked. From there, then you have, as you might see, you have prototype definitions and you have the points. So if you click on the points, you can create a value, but what really wanted to do was to basically define what's happening or how this is going to be built. So if you go inside of here, and my friend, engineer from Autodesk, Guillaume Laforge, is the one who actually did this. You will see he's basically building the point positions, he's putting everything into an array. He's getting a lot of mathematical stuff that I'm not able to explain, but that's why I'm sharing this stuff with you. But you see you have a pi node here, they have a value node as well, which float, and he's multiplying this and also dividing by certain things. And this has a y, but basically he's just converting everything in here, which is basically just figuring out, like I said before, the distance between the pod and the center of the cylinder, just figuring out the distance there, or the circumference, the radius, and they just outputting it, right? So this is why, if you go back into here, you will see I have a radial, vertical count, all this stuff. So it's figuring out all this stuff. And let me go and show you something pretty quickly. So if I say put the radial count, say only to 2, you see how it just basically creates the one right on the other side, because it's multiplying right basically by the distance. So it just basically saying second one goes right over there, and if I keep multiplying, it's actually adding and multiplying. So it's adding and multiplying. If I say do 3, now it's basically again using that circumference, using the ratio of the length of the circumference to kind of figure out where to place the third one, and so on and so forth. So if I do 4, same thing as you might see now as completed the circumference. So now I know then obviously it's 27 because I counted 27 spaces. So if I do 27 here, then voila, now I completed the entire thing. So like I said before, if you move this up, then you know there's 649 units in Y, so in the Y axis. So if I do 2 now, it will add a second level of all of them. And this is basically what he's doing. This is just keeping all the data. So all the data that I did first in the radial count, then add it on top the second and the third and the fourth story. So if I have, say, 4 or whatever, or 5 or 6, this is exactly what it's doing. So it doesn't matter how many I input, it's always going to do that. And if I take on the radial count, say I'm going to only do 10, so it's still keeping, right, that information. So I can still modify this. Say I want to have empty spaces or something else in the middle, I can still do that. But this is how it's intended to look, right? So it's a full tower of pods. It's pretty much just a battery. Okay, so again, so that's how we define the points, or how the engineer defined the points. So next step is just to say, okay, well, where's he getting this information from? So you still need to define where to find that information, or what is the reference layer that it needs to use. So that's why you have the prototype definitions over here. So let me again just expand this. So if you right click here again, you can define USD prims, which will give you again another X form, which you will have to change the prim path to something. In this case, I call it tower. And from there, I created a reference definition once again. We remember last time we were using the layer in order to find the USD file. But because the USD file is already in this case, what we want to use is all of this stuff here, right? So we want to use this USD file that has the reference, that have been repurposed and all that. So for that, I'm going to take this path. So that's why the prim path is important. So I'm going to take this, I'm going to copy that. Basically, this is all you're doing. And you're going to specify at this, instead of a layer, you're going to do a prim path. So if I disconnect that and create a value node, it's just going to give you, that pretty much. And then as you may see on the value, it just asks for a path. So, and it's the string type. So I need to input the port, and that's pretty much it. So that's it, right? So it's still going to use that. So, so let me delete that. I already had it, and reconnect that. And that's how we are getting all of this information that is already there in here. Instead of getting exporting this as a USD, which you could, as if you wanted to export this as a USD and then bring it in as a layer, you could also do that. But I want to keep it as a prim path just in case I don't want to lose any data. I want to be able to also change certain stuff, or maybe I want to be able to add more stuff and, you know, dynamically keep all that information. So, but again, if you wanted to export this stuff before the add to stage here, you can add a save to USD stage node, right? And then you need to connect from this guy to this guy. Then you obviously need to output it. So you need to put it into an output, which is not going to be that one. We need to delete that port, sorry. That's another one. So create a new one, and then you need to make sure you go and save it here. So say whatever, give it a name, .usd, and whatever you want to save that, and just enable it. Once you enable it, it's going to get saved, and you are all set. You can save the file, go back, and you can then disable that, do whatever you want. In this case, I'm not going to do it because I want to keep everything in here. So that's how that works. So that's, as you can see, pretty straightforward. And next step is now getting again another point instancer to take the tower building, which we had here, and then just scatter around a plane, which is pretty much it. So let's go ahead and see that. Okay, first thing, again, it's going to be to add a stage, or add another node called add to stage. So this is the one that is here. Again, just to keep them separate, right? So we'll have different hierarchies, so everything's separate here. But that's the whole reason. In this particular add to stage, Instead of keeping it under a different X form or a new X form, I just went ahead and just created the USD Point Instancer. Let me move this up here. Just created the Point Instancer directly. So which is what you see here. So the Point Instancer, in this case, I'm going to call it Towers City, because this is what it's we're going to be using to build or scatter that tower that we built before around or across a plane. And it's pretty much the same thing. So in this case, to define the point instancer, I use the scatter points node, which is right here. So scatter points. As you see, the scatter points is basically this node here. So if I expand this one, just use the same one. It's nothing new there. And then I use the plane, pretty much just the plane, which is here. This level, so call it ground in this case. So that's the plane that I use. It's not that big, to be honest. So as you see, because it's using points, you don't want to subdivide it by a lot. So I just keep it simple. In this case, I just have 5 and 5 subdivisions, and it's got 40,000 units height and 38,000 units width, which is in centimeters. So I'm talking about a big plane over here. So again, let's going back. If I expand this, you will see the difference. So this is an X form, this is an X form, but this is not really an X form. It's just basically just defining the towers of cities, on a particular point instance. So this is why the icon changes in there. So in order to get, I'm sorry about this, in order to get that plane, if you didn't know, in case you didn't know, all you need to do is just little mouse click and drag and put it in here. So that's how you get the plane. And then you just need to connect this into the geometry, which is very straightforward. And in order to proceed then and create the prototype definitions, we do the same thing as we did before. We just right click, get a new X form, we give it a name. In this case, it's going to be called a city. Then we create reference definitions, and the same thing, we create a print path, and we're going to specify the print path. So the print path in this case is going to be this other guy, which is the one that we used to build the entire building. And this is the main reason why this needed to be on a specific level, because if I didn't put an X form before this, then it wouldn't know how to deal with this data, right? So all I wanted to ask Bifrost was, okay, now I have a building, now I want you to scatter the building. So that's why I needed to have this X form first. And that's the whole main reason. So, and all I need to do now, again, is just to input the print path into this value, pretty much here, and we're all set. Now I can go into my scatter point node, and I can start adding, more buildings. So say I'm gonna add 2. And it goes and finds, points, multiplies by 2. So it's exponential, I guess. So if you do 4, then same thing. So 6. And I'm also using, as you might see, the scatter mode. I'm using blue noise. Seems to be better than the random one. So I don't know, it's more natural. It also doesn't really, as you might see here, they're not on top of each other. So blue noise give me that, a little bit more natural kind of looking, also looking thing. So I can also adjust the seed here. So you might see, you can adjust that. But the good thing now is that if I needed to change anything in here, say, okay, these guys are actually colliding, I don't know, I can just pretty much non-destructurally and procedurally now can start changing this. So say I want to add more width, and this we're talking about 38,000. Let's add, I don't know, double or 60,000. 1, 2, 3 in there. And we'll do maybe 100,000 on this guy. There you go. So now, we have more separation between those buildings. Let me uncheck that. And now also we can start adding more and more buildings, and make it a little bit more crowded. And in here, we can use blue noise maximal. You see that also helps, you know, keeping them away from each other on this here. And that's pretty much it, guys. So now I have an entire city, you know, that I can use to render quite nicely. So I have a full building. You can obviously make this a lot more complicated. You can define a path. You can, I mean, there's a lot you can do to improve on this, but I guess this is just a proof of concept and use case. That's quite nice. I believe, and I want to show everybody. So now again, because this is is procedural, I can, you know, basically go back in here and go into the construct points, and I can maybe add more stories to all the buildings. As you can see, now they're a lot higher. That's it. As you can see, you know, it's quite straightforward. So next thing we're gonna do, add a couple of lights, and we're gonna render this. You know, I just want you to see how fast you could render this. You know, you don't really need as many lights. You can either use 3-4 lights in order to get a real nice looking city. So it's basically that same city, or let's call it shot, or buildings, right? Let me hit play. This one I'm going to be rendering pretty much. So I just got this character in with a little bit of an animation, imported it in as a USD file as well. So you can see you have the entire thing here, the buildings and all this stuff. So I'm still able to go back and take the pause, right? You can see you have the default one. So, but I want to use the open in this case. So I want to use the open pod. And now I'm ready to start rendering this, right? So I'm just going to explain what I have. So it's very straightforward. And let me just go into a different camera. So camera, this other camera here. So I have one big area light here. And this one is just basically giving me a little bit of an atmosphere. And I set it up right over here on the Arnold environment tab under the render settings. You have the atmosphere volume. So if I click here and go to attribute editors, you will see you have just a regular AI atmosphere volume with the density set to 0.003. So I just don't want this to be too crazy. And just, you know, just a simple setup. I have another directional light to give me some shadows, and I have another area light over here, which is actually the one lighting the character on top. So this is for the character. I have one light for the character. I have another light there to give me more atmosphere, and watch that I have the volume set to say, you know, it's not full. To 1, but it's mid, you know, way up, so it's 0.5, and that's pretty much it, right? So it's very straightforward lighting setup. So I have basically just a key light, then I have a rim light for the character, so give me a little bit of a white around the edges of the character, and that's pretty much it. So let me then go back to my perspective camera and let me see if I have a bookmark. Did I? No. But anyways, I'm just gonna render. Let me render this particular frame here over here. And if I go into the render settings, you will see you have. Let me even lower it down a little bit, so this goes a little bit faster. So going to start like that. I'm gonna do. You can do adaptive sampling. I'm gonna turn it off for the moment. But eventually I will do it, but I'm just gonna turn it off for the moment. And what else? So let me go into the Arnold render view now. And this is over here. And let me open this. So what I've done in order to work on my look depth, and everyone should do this, is basically add just an imager. So if you go into here, you can add your imagers, and you have the denoiser Odin. I'm using actual CPU to render this, so I found that the Odin dinosaur is quite nice. Okay, so then what I want to do now is just hit render C, so start tuning this in. So I'm just gonna collapse this and let's give it a go. Okay, so that's it for today. I think just to recap what we've done today, we first exported models, as USD. We were able to keep all the lighting, shading, and textural information within that USD file. Then we use that USD file instead of Bifrost to create variants or to store variants, and also purpose it so you would have a proxy version that it's only appearing at the viewport, and then you have a render version that again has different variants that you can choose from in order to render. Then we created an entire building out of this one particular module using construct points and point instancer USD, and then again we use another point instancer to create an entire city and finally render this. So I guess the message for you guys today is thank you for watching, and remember you can also use Maya as your hub for all things USD. But if you want to collaborate, you can always export this into a USD file and share it with anybody else, to use in Houdini or Cinema 4D or whatever there is that you want, as long as you're keeping your Arnold shaders and you're keeping Arnold as the main render. If not, you can always export without shaders. But that's it for today. Thank you very much. Again, I'm JP, and I'll see you next time.